Welcome back. In this class, we'll look into some array functions. As I said in the first class in this section, this NumPy comes with a rich set of functions to manipulate all these multi-dimensional arrays. Okay, let us see some code examples. There's a method called random on NumPy. We can use that one. We can say x equal to npy dot random dot rand int, and if we pass two numbers, it will give a random number between these two numbers. If I print x, I'll get a 4. If I do it again, I get a 3, and similarly if I do it one more time, I get a 5. It is always between 1 and 10. And next, let us create two list objects using this rand function. Let us write a small piece of code. I'll say x is a empty list and also y is a empty list. All right. And then I say for I in range, let us say 10, or take 5, range 5, colon, I'll say x dot append. I'll pass this one. I'll say I'll pass this function here. Okay, and the append, this is append, and also let me copy this one. I'll do same thing for y. So it will create two list objects with random numbers from between 1 and 10. And let me change it to range 10. And if I print x and y, let us see what we get. So we got two list objects. This is the first list, random numbers between 1 and 10. All right, we got two list objects. Let us convert these to arrays. How to convert? You can say x equal to np dot array, and let us pass that the list objects x, and similarly I can say y equal to np dot array, and let us pass y. So that will convert x and y to arrays, one-dimensional arrays. If you see the arrays, these are the two arrays. All right, and let us try a function on this. We can say np dot add x and y. We are adding two one-dimensional arrays. See what we get. So each element is added. 3 plus 8 is 11, 5 plus 1 is 6, 2 plus 9 is 11, and similarly 8 plus 5 is 13. So each element is added. That is it. That's what we get. Also it comes as an array. The output is it returns an array with all the items added. And also let us what is x now, what is y now. There's a function called maximum. If I say np dot maximum, and if you pass the two arrays x and y, it will create an array with all the maximum values. See, between these two, 8 is the max, so it took 8. Here between 5 and 1, it took 5. Similarly between 2 and 9, it took 9. So it creates the maximum of both the arrays. Similarly, there is something called a minimum. np dot minimum of x and y, and if you execute this, you get a minimum of, see, between 3 and 8, it is 3 is minimum. Between 5 and 1, it's a 5. 1. And also there is something called square root of, we can do np dot square root. Maybe we can pass the minimum array to this. Let us pass this minimum array to the square root method. If we execute this one, we get the square roots of each of these items. The square root of 3 is this one, and square root of 1 is 1, and the 2 is 1.4, and also there is the 2's here. If you see 1.414. So that is about, also there's a method called square. Let us see what is x now. Okay, let us say np dot square, and if we pass that x, then it will give the squares of each number. See, 3 square is 9, 5 square, 4 square, 2 square, 3 square, and all that. And also there's a divide method. It will do an integer division. See, let's see what is x and what is y. Okay, if I say np dot divide and pass x and y, that will do an integer division. See, if when 3 is divided by 8, you get a 0. Similarly, when you do a 5 by 1 is a 5, and 2 by 9 is a 0. So it just does integer division. And also there's a power of, let us do np dot power, and we'll pass the 2 arrays. Then you will get, if I execute this one, we'll get power of, the first one is, let us see, oh yeah, this one, 3 to the power of 8. Let us say 3 to the power of 8 must be 65, 61. Similarly, if you see the last one, 8 to the power of 5. 8 to the power of 5. 32, 768. That's how to find the power of an array with the 2 arrays. So we have mod method. I can say, let us see x now. Let us see x and y. All right. If you see, if you do a np dot modulus of x and y, this is what you get. You get modulus 3 by 8. 3 modulus 8 is 3, and 5 modulus 1 is 0, and 2 modulus 9 is 2, and all that. And also let us see, there is a sort method. Let us, what is x now? X is 3, 5, 2 something. If I do x dot sort, if I do x sort, and if I print x, it will sort all the numbers, and it will also store on into x. Similarly, if you do a y sort x, sorry, we do a y sort, it will, and we have to print y. All right, y is also sorted. And if you do, let us say there's a unique method, you can say np dot unique and pass, let us say pass x will give you, because there are so many 2's here, so everything 2's and 3's and 5's are all duplicated, then it will give 2, 3, 5 and 8, 9. Those are unique numbers. Let us see, let us get back our original random numbers. Okay, Let me create it back. I got two lists. Let me convert it into the objects. All right. And this is my x and this is my y. There's a method called greater method. Let us see what is that. Let's say np dot greater, and if I pass the two arrays, I'll get a Boolean array. It says is 2 greater than 2? No, that's why you got a false. Similarly, 7 7 is false, 2 8 is false, 9 9 is false, 3 5 is false. Then we get a true. 9 4 is a true. 9 is greater than 4. That's why you got a true. Similarly, let us say the rest of them is all false. So x is having lower numbers, most of the lower numbers than y. So np dot greater will return a Boolean array with all the Boolean values. Let us save this one too. Let me copy this. I'll say np, just say b equal to, the b is a Boolean array. If I print b, that is Boolean. There are some methods on this Boolean arrays. I can say all. It says false. All means or all the values true means it's a false. And if you say b dot any will return a true, means are there any values that are true, means because there is one true value, so that's why you got a true. So a couple of methods on the Boolean arrays, and there's one more method on equal. Let us say what is x now and y is this one, and if I say np dot equal, and if you pass the two arrays, you got another Boolean array, and it says if the values are true, if the values are equal, then it will give a true. 2 2 is equal, that's why you got true true false and again true. All right, that is about equal. It checks the two arrays. And actually, if you go to this site, let me copy this site here. If you go to this site and if you go to this site, there's a reference on this all these universal functions. Let us go to that site. I'll show you. So these are all this is on the SciPy website. All the universal functions on the NumPy reference, and if you see all these functions here, so the math is basically these are methods on NumPy. Add, subtract, multiply, divide. We saw this divide, and there's a power of, we saw mod, and there's absolute one, and the exponential ones, square root we saw, and square we saw, and also there's a reciprocal, and also there are trigonometric functions and bitwise functions, and comparison operators. We saw some of these, greater than, and we saw equal, and some logical methods. We saw max and minimum. All right, there's a lot to explore in these websites. And okay, we'll stop here, and we'll meet in the next class. Okay, thanks.